I just got done making this solid copper ice press that turns pieces of ice like this into perfect spheres. It works amazingly well. This thing's a perfect sphere. So cool. I just wish we could see what was going on in here. So in today's video, I'm going to remake this piece, and instead of having copper around this area, I'm going to replace that with clear acrylic. That way we should be able to see exactly what's going on all the way up until the point where it becomes a perfect sphere. And that should be incredibly cool when it comes time to put dry ice in here. That's crazy. Whoa. I did that in my last video and the reaction was really spectacular, so it'll be really cool to actually see what's going on in there. In my last video, I showed you how I used lost PLA to make these pretty complicated parts. And I'll be using that same technique to make this part. This great big piece here is called a riser. It'll just supply the main casting with metal as it solidifies and shrinks. And it has to be really big like that so that it's the last part to solidify. I'll also be able to put it in the lathe like this and machine down this section so that this piece of acrylic slides over. And then I can switch it around and machine this down and turn that into a handle. So here's the shell after I burned out all that plastic and turned this thing into ceramic in the kiln. It looks really nice, there's no problems at all, it didn't crack or anything like that, so that's really good. Now I'm going to stick it back into the kiln, turn it up to about 1500 degrees Fahrenheit, and then pour in the molten copper. Right now I'm in the process of weighing out all the copper that I'm going to need for this project. The CAD software that I use tells me that I need 5,500 grams for this casting. This is one of the pieces that I'm going to melt, and it's the sprue from this piece here. Big pieces of metal like this take a long time to melt, so I cut it in half, and when I did that I revealed these large pits in it. That could be a problem because the sprue on the casting that I'm making now is a very similar size to this, and if it's full of holes then I'm not going to be able to use it as a handle, and that was my plan. So I hope I don't have to machine a new handle because that's going to be a lot of work. When you load these crucibles you have to be really careful because if you wedge pieces in here, they'll expand as they're melting and they'll actually crack the crucible. There we go, that'll work. Right before I do the casting, I'm going to add just a little bit of this phosphor copper to the metal, and that'll degas it and make sure that the casting doesn't come out really porous. Here it is after I broke off the shell and cleaned it up a little bit with the sandblaster. All of the important parts look really good, but unfortunately there is some shrinkage around this area. I'm not really sure why that happens, but it shouldn't be an issue because I am going to be machining most of this away anyways. My original plan was to make a handle out of this piece, but the more I think about it, the more I realize that the odds of it being solid are really slim, so instead I'm just going to cut this piece off and I'll make a handle out of this piece of copper bar stock. Well, I was definitely right to be worried about it because this looks awful. Not exactly sure what I'm going to do about that. My original plan to attach the handle was to drill and tap a hole here, but obviously I couldn't do that, so instead I just bored it out and now I can just press the handle in without the need for threads. That worked really well. Now this handle's definitely locked in place. It's not going anywhere, so I'm really happy about that. I thought it was done at this point, but I remembered that I actually wanted to drill a hole going from the top of the handle into this cavity here, and that's going to help with drainage. Obviously the time to have done that was when this thing was chucked up in the lathe, but now that it's out of the lathe, I'm just going to use my milling machine. And the reason I'm going to use the milling machine instead of the lathe is because I don't want to put it back in the lathe and further damage this really soft copper. You can see that it does leave some indentations there, and I want to avoid that as much as possible. Fortunately, I do have some of these stub flute drill bits, which are a lot more rigid than a normal drill bit, and because I have to go through quite a bit of copper, the rigidity of this drill bit will hopefully prevent it from kind of wandering off, and I should end up with a really straight hole. It might still wander a little bit, but I think this will give me the best chance possible. Did I say I was going to drill a hole? Well, what I meant was, I'm going to drill a hole and then break a drill bit off inside of it, getting it completely and hopelessly stuck. No idea what I'm going to do now. Good thing I was using that fancy drill bit, huh? I think I came up with a solution. What I'm going to do is just flip it around like this, and then I'll drill down from this side, and when I feel the drill bit, I can use a punch and just kind of knock it out of there. Hopefully that works. All right, I can feel it with a drill bit, so let's see if I can knock it out with a punch. Oh yeah, it's moving. There it is. Well, I finally got that stuck drill bit out of here, which is a big relief. Now all I have to do is clean it up and then try it out.